The target here is given functions f and g in symbolic form, write formulas for f composed with g and g composed with f in simplified form. From the last learning target, we should know the definition of composition of functions. Here, let's restate it. Given two functions, f and g, the composition of f and g, denoted with the little f circle g, is f composed with g of x equals f of g of x. That is, you take g of x and plug it into f. Here we have two functions, f of x equals 1 plus x, and g of x equals x squared. So if I want to look at this composition, f composed with g of x, that is, I'm plugging g of x into f, and f says whatever is inside of me, do 1 plus that thing. So g of x is inside of f, so it's 1 plus g of x. But now g of x equals x squared, so we have 1 plus x squared. That is, f composed with g of x is the function 1 plus x squared. Let's look at it in the other direction, g composed with f of x. So we're going to be plugging f of x into g. G says whatever is inside me, square it. So f of x is inside g. So we have to square f of x. But f of x equals 1 plus x. So we have 1 plus x squared, which is equivalent to 1 plus x times 1 plus x. Using the distributive property and simplifying, we have x squared plus 2x plus 1. That is, the composition g composed with f of x is x squared plus 2x plus 1. Let's look at another example. Let's look at the function f of x equals 1 over x minus 4 and g of x equals x squared again. So we're going to first do f composed with g of x. So we're going to be plugging g of x into f. F says whatever is inside me, do this to it. Put a 1 on top and then put that thing on the bottom and subtract 4. So simply 1 over g of x minus 4. And g of x is x squared. So f composed with g of x is the function 1 divided by x squared minus 4. Let's compose in the other direction, g composed with f of x. We're going to be plugging f of x into g. So g says whatever's inside me, square it. So we square f of x. So we take f of x and square it. But f of x is 1 over x minus 4. So we have 1 over x minus 4 squared. And squaring that, 1 times 1 is 1, and x minus 4 times x minus 4 is x squared minus 8x plus 16. So g composed with f of x is the function 1 divided by x squared minus 8x plus 16. Let's look at another example here. We have the function h of x equals x cubed plus 5, and we have the function I of x equals x. So if we want to compose these two functions, h composed with I of x, we'll be plugging I of x into h. H says whatever is inside of me, cube it and add 5. So it's going to be I of x cubed plus 5, but I of x is simply x. So we have x cubed plus 5. Notice that it didn't change, that we did h composed with I, and we got the same output as h of x, x cubed plus 5. Let's go in the other direction, I composed with h of x. So we're going to be plugging h of x into I. So h of x, I says whatever is inside me, just spit it back out. So I of h of x simply equals h of x. And h of x equals x cubed plus 5. Notice in both directions here that h composed with I equaled x cubed plus 5, that is, it equaled h, and I composed with h equaled x cubed plus 5, that it equaled h. So this I did not change h in either direction. And that leads us to what's called the identity function. The identity function with respect to composition of functions is the function I defined by I of x equals x. Just like our operations in multiplication and addition. With multiplication, we have the identity element is 1 because 5 times 1 is 5, or 1 times 5 is 5. The identity element with respect to addition is 0. 5 plus 0 is 5. 0 plus 5 is 5. With respect to composition, the identity function is I of x equals x. And to see that a little more clearly, so assume we have f as any function and x is a number in the domain of f. What we're going to show is that when we compose f with I, that it does not change I. Just like in multiplication, multiplying by 1 does not change the thing that we're multiplying by. Or with addition, adding 0 does not change what we're adding. So if we take f composed with I of x, remember f is any arbitrary function, but I of x is specifically I of x equals x. We're plugging I of x into f, but I of x is x, so this is simply f of x. So we compose the f with I, and our result is f of x. In the other direction, we have the function I of x equals x, and we're composing with an arbitrary function f, so we're plugging f of x into I. But here I says whatever is inside of me, spit it back out. So it's simply f of x. And this is why we call the function I of x equals x the identity function, because when you compose with it, it doesn't change the thing that you're composing it with. F composed with I is f. I composed with f is f. And that will end this video instruction on the learning targeted composition of functions. Thank you.